Today's video is going to be about standard deviation. This will be useful to you if you are on the BTEC Applied Science course doing the Unit 3, but it will also be useful to you if you're doing any biology qualification with us. Okay, so imagine two classes recently took a quiz. Imagine there were 10 students in each class, and imagine that each class had an average score of 81.5. Now, since the averages are the same, can we assume that the students in both classes did pretty much the same on the exam? Well, the answer is no. The mean itself does not tell us much about how did different people do. We just have the very average result, but we do not know how high or how low the rest of the class scored. So if we're looking at a graph of this, we may see something like this. Imagine group A. We have the average of 81.5, but you can see that the spread of data here goes from about 72 to about 89. What about Team B? Their spread is even bigger, starts around 56, 7, goes to about 98 here. Okay? The mean is exactly the same, but it does not tell us enough about this set of data. So we need to come up with some way of measuring not just the average, but also the spread and distribution of data. Now you could say, we could do the range. We could just give the mean, the lowest, and the highest number. But again, if you saw this graph with the average and the range, that doesn't necessarily tell you how many people got around the mean. Okay, so here we have quite a lot of pupils scoring right around this mark, but just giving the mean and just giving the highest and the lowest value will not necessarily show that. Okay, so most numbers are in this area and they are not evenly distributed throughout the range. This is what we're seeing here. So the definition for standard deviation that you need to know is that it is a number that measures how far away each number in a set of data is from their mean. If the standard deviation is large, that means that there's a lot of spread of data. They're located quite far from the mean of the data set. If the standard deviation number turns out to be quite small, then that means that most of the numbers are located quite close to the mean. There's not that much variation. In a graph, it looks something like this. You've got a thin curve here that shows you that a lot of the values are located close to the average, whereas for high standard deviation, we see that there is more spread, so there is more variety. The range is bigger, and there are just more values further away from the mean. Now, there is an equation that you will need to know for standard deviation, and it does look a bit scary when you first look at it, but make sure you write it down and annotate along. Okay? This is the equation itself. You will be provided with this in some exams, but not others, so it's always worth to try to memorize it as much as you can. We will use a table to try to figure out what this all looks like when we try to visualize it better, but for now we're just annotating what all of this means. So we start with this x. This x is each individual number in a data set. We then have an x with a dash on top, and that is always the mean. There's the little 2 there, right there. That's your squared. You'll recognize that easily. This number you might have not seen before, the symbol, sorry. That's sum of. So the sum of each individual number minus its mean squared is the top of the equation. Then if we go underneath, we've got this n. That's the number of data points in that particular data set. And then it's always minus 1 there. Final step is this shape here, and that of course is the square root. So I'll work through an example with you, and then you can have a go at doing this yourself. Standard deviation is easiest done in a table. I think visually it helps a lot. So if you imagine you've got your Team A score quizzes, so we've got the lowest score being 72 and the highest being 89. Now our first step is we do need a mean. So to calculate a mean, you would add all of these numbers up, so 72 plus 76 plus 80, so on and so forth, and divide that sum by the amount of data points you have. which we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So whatever this number is added up, divided by 10, which for us is 81.5. So we know our mean. Now, this column is showing us the distance from the mean. This is that very first part of your standard deviation equation. Each data point minus the mean. That's what we're trying to solve here. So, we start with the first one. This is the first data point minus the mean. The mean was here. That gives us minus 9.5. And we carry that on. Next is going to be 76 minus the mean. There you have it there. I'll reveal the others, but it's always the same thing. The data point itself minus its mean to give you sometimes a negative, but sometimes a positive number. Okay, always the number minus the mean. That's the first thing that we do. Now the next step is to square that. You remember that square sign from the previous slide? That's what we're going to do here. So we're taking whatever this number was, all of these, and just squaring them. And that will always remove the negative number, the negative symbol. Sometimes your calculators don't do this, so you have to be quite careful and just remember that anytime you square a negative number, it becomes a positive. So the first one is minus 9.5 squared. That gives us 90.25. And we carry that on. Next one is minus 5.5 squared. That gives us 30.25. You carry this on until you reach the end. And then this is where we can now sum up. So we have this whole top of the equation now. We have added all of these values together to give us this sum here. Okay, this is the very top of the equation we've now solved. So if we look back at the whole equation again, here is the top. We've already solved that. That was 214.5. We can see that we need to divide that by the number of data points minus 1. If you remember, there was 10 data points. That means 10 minus 1 is 9. That gives us 23.8. Now, quite a few people would stop the equation there, forgetting that actually there's still the last step. We still need to do this square root. And that's our final step. Is square root of 23.8 gives us the standard deviation of 4.88. Okay, the spread of data around the mean for this particular sample is 4.88. Now, to check that you've understood that, I would like you to attempt it here with Team B quiz scores. Okay, I've left the table blank here. You can copy it down into your exercise books or into Excel, whatever you wish. You need to fill in what should go in this header, fill in what should go in this header. Remember to calculate your mean first and have a go. Okay, so this is ideally what we should have at the end. We know the mean for Team A, we know the standard deviation for Team A, we want to find out the mean for Team B, and we want to find out the standard deviation for Team B. In terms of what the results should be, so if you stop the video now and try to solve it for yourself, when you come back again, you should be able to just check that you've got your correct results. For us, the mean should have been 81.4 and the standard deviation for Team B is 16.09. Now that means that there is a lot more spread of data in Team B. That means that there's a lot more data that's close together, closer to the mean in Team A. Okay, so both Team A and Team B had the mean score of 81.5, but the standard deviation for Team A was smaller than the standard deviation for Team B. And that means because Team B had larger standard deviation, the values must be more spread around the mean. So the scores are less consistent. And if we were to quickly just flip back to look at that, we can see that Team A scores went from about 70 to just under 90, whereas Team B scores went from about 56 to almost 100. So you can see that there's a bigger range, but the standard deviation is also showing us how closely related to the mean these scores are. Okay? And that's standard deviation.